Welcome everyone to another session, Data with Nikk the Greek. This is the second part of Load Big Data Efficiently, and today we really deep dive into different data formats to understand how they're working and why we're doing it. The data format has a significant influence on your performance when loading the data, of course, but also when writing the data, how the schema is interfered, how the size of the data is. And that's something we also already saw in part 1 of this series, where we analyzed different formats and observed how the performance in Spark is looking like. So if you missed this episode, I have the link here above in the screen. So just click on the link and check it out. So goal for today is that we have a short recap on the performance results to take us as a basis before we deep dive afterwards on the very basis of data formats, row-wise versus columnar data formats. That's how all the formats on the higher levels are usually structured. And then we're gonna have a look deeper into the selected formats, AVRO, PARQUET, CSV, and JSON to understand how they work architecturally, but also what the benefits and disadvantages of those formats are. So let's get started. So let's have a look now on the size, write, and loading times of our previous part 1 performance evaluation. So here we have JSON, CSV, PARQUET, and AVRO. And we can see that for PARQUET and AVRO, the size is significantly lower. Look at the writing times for all formats except of AVRO. The writing times are quite similar, but AVRO is here the winner with 3.5 seconds compared to 6.6 seconds of writing time of 1 million data, 10 million data to say. Looking on the loading time, we can see that PARQUET and AVRO are really fast compared to the other formats. Also to mention that CSV has 2 options when loading the data, either with or without schema interference. Without schema interference, it looks for the schema on your first row, which is not very accurate. And with schema interference, we're gonna have to look through all the data to interfere the schema. And I did here 2 comparisons, so JSON versus AVRO, for instance. So you can see 94% size and cost savings are there. And why also cost? I did a small calculation on the right. Let's imagine we have 100 terabytes, 100,000 gigabytes of data, and then 94% less size means 6 terabytes or 6,000 gigabytes. And when I'm looking on the Azure Data Lake storage costs, which are 0.02 euros per gigabyte roughly, we see that we have 2,000 euros per month on cost versus 120 euros. So we save just by choosing another format 1,880 euros per month. And on top, we also have a faster writing and loading time with 62 and 80%. And similarly on PARQUET, also the size is lower there when we compare PARQUET with CSV. The write time towards CSV is similar, not significant, but then the loading time, of course, that's where PARQUET performs really well across all the formats, even AVRO. If you're looking in the Spark UI, we're gonna see where the loading time difference are coming from. So the metadata part is where the schema had to be interfered or loaded, and their JSON CSV, if using inferior schema, needs a lot of time. And PARQUET and AVRO are quite fast there. So PARQUET still has some schema which is loading. AVRO is basically containing it and loading it directly together with the file of the data. And that means the observation which we had were there that AVRO and PARQUET seem to be highly compressed and significantly smaller than CSV and JSON. Despite the compression, writes are up to 50% faster, especially AVRO, and reads are also significantly faster than for CSV and JSON. And well, PARQUET and AVRO seem to provide the schema correctly. So with CSV and JSON, we realized it doesn't. JSON, for instance, doesn't understand timestamps. CSV was even worse. And PARQUET and AVRO seem to contain meta information. PARQUET needs a separate job, and the CSV and JSON also need a preliminary job to interfere the schema, which is very cost expensive. So now let's have a look on the different data format types. So generally we can split data formats into unstructured, semi-structured, and structured formats. So unstructured are, for instance, text, videos, sound, and pictures. And those are basically unorganized and unformatted information and data. Then we have semi-structured formats like JSON, XML, which contain tags or markers, and that create some structure or semantic, but it's not really enforced. And also to say CSV, you find sources which rather say it's an unstructured format as well, because basically you have a very flexible structure like the comma separation which we have there. And then we have very strict and structure formats, PARQUET and AVRO, which have strict data type rules and enforce the schema. And that's where we're gonna be putting our focus, JSON, CSV, PARQUET, and AVRO today. But before we're gonna jump into the formats, we first of all have to understand on a high level also what are row-based and columnar storage formats. So I created here a data frame as an example. So we have a string column name, we have a Boolean column female, which is false or true, and we have an age, which is the age of the people we saved in this table, which are integer values, numbers. And when we are saving data on this, we have the row-based wise, so bit by bit or byte by byte, the data gonna be written after each other row-wise. So that means Stephen falls 33, Peter falls 47, and so on. And on columnar side, we're gonna have them on columnar level. So first of all, we start with column name, so Stephen, Peter, Anna, Laura, then with a female column, false, false, true, true, and so on. And you see that we have some kind of blocks there. So on this, we have a further separation on blocks. And this block basically means there's a minimum of data on this or file system which can be written or read. So you cannot read less. So always you're gonna read at least a block together. And so what's also important is fragmented data. So data which is like not very close physically on the disk, gonna be more difficult to read or slower to read than physically close to each other data. So let's think about it with some examples as we understood what blocks are. So let's say we want to read the first row of our table. So then on the row-wise level, it gotta be quite easy. We're just reading one block. But now let's say we want to calculate the maximum age, which is 47. But first of all, we need to get the ages to do this. And those are distributed in all the blocks. So we have to load all the 3 blocks, or all the data in this case, to just perform this calculation. Let's perform this calculation on the columnar format. There we only load block 3 and then calculate our maximum. So we just load, roughly said, 1/3 of the data in this case. Let's now load the first row of our table. Again, the data is available in all the blocks. This process is again slower. So, and by that we can come to the conclusion what are the benefits and usage of those 2 different formats. So if you have write-heavy transactional workflows, you just save the data row by row. That's really fast. Also, if you want to loading the data all by row, so always all the data by row, or want to do row-based filtering, also quite efficient on row-based level. On the other hand, columnar levels, well, lead of course a little bit more write time because they save the data in columnar. You can just can't just save them based by row, and their focus and bring benefits into read-heavy analytical workflows. So if you want to read only part of the data, so on column level, or you want to do aggregation calculations like sum, max, min, and so on. So that's where the benefits are. So, and now let's jump into the different data formats. So CSV is a comma separated value. And this format was developed by IBM in 1972. And it's a row-based format, so it's fast when writing the data usually. It's human readable, so you can see an example on the right where we have, well, Spark when saving, change the columns. But basically we have the data saved with comma separate in this case. And so, well, it's quite flexible, so we can choose different separators like semicolon or even space. We can add or leave out the header, etc. And well, this flexibility also has disadvantages. So for instance, imagine here in Germany, sometimes we have decimal numbers with a comma. So very annoying mistake. Also, you have the option to have spaces for separation. So imagine you have a string now which which contains spaces. And it's also not a self-describing format. So self-describing means there's no information about what the data is about, how the data is structured. So there's no schema defined. So as an example, look at the female column. So as a computer, could you understand that this is a Boolean column compared to the name column? So it looks exactly the same. So in other formats, you can better identify that we have a string and a Boolean. We also in our part 1 had the issue that we saved numbers as strings, but then when loading the data, interpreted as integers. And that's exactly an issue which will come up with CSV. So to have like the data properly defined and saved also in the correct format. And interfering it or casting it later on costs, of course, again, performance and loading or calculation time. CSV has compression options like gzip, snappy, which also PARQUET and AVRO are using, but it's not human readable anymore, and also not as performant as with the other files when doing some compression here. And well, there's also some splittability in the raw format and for some compression modes, for snappy for instance not. And splittability means that data can be split into pieces so that data like in Spark can be in parallelly processed, which speeds up of course the performance. On the other hand, CSV of course has a high support, so you can open it with nearly any text editor, and even Excel of course is supporting it as a bigger, heavy application. Let's come to JSON, JavaScript Object Notation. So this was first specified in early 2000s, and it's also a row-based format. It's fast when writing, and it's human readable. And so you can see also an example on the right side. And compared to CSV, it's self-describing, meaning it contains information describing the data. So if you're looking in the example above, you can see that age is a number because it doesn't have the two lines up there. And then female can also be seen that it's a Boolean because it's a string but doesn't have the two lines. And then we have a name, Stephen, where you can see how it's marked as a string. And of course, Java also supports very nested structures, so you can add another struct types, arrays, objects, integers, booleans, nulls is all supported. Now, of course, strings. Dates are not supported. That's really important. That's what we also saw in the first part. And well, we have an issue here because you see that all the column names are duplicated. So imagine you have 10 million of rows and then maybe 20 columns. You're going to see all the column names, like here, age, female, name, repeated. And this creates, of course, a big size. Also here you have the option to do a compression, but depending on the compression mode, the splittability gonna be not working anymore, so no parallelized reads and executions. And also you have a multi-line option, which should be false if you want to do parallel reads. What's also important is, so JSON is often used as default for REST APIs. That might make sense, but if you want to save and work with big data, I wouldn't recommend to use JSON necessarily to write the data. Except if you want human readability, then there might be an option. But usually you want a format like AVRO. So AVRO is around, well, available since around 2009. It's also row-based format, and it's fast, really fast when writing, as we also saw previously. And it uses out of default a compression, snappy with aiming high writing speeds. And it's also binary, so it's not human readable. even though you have the option to save also the data blocks, the core blocks at JSON. But this slows, of course, the whole process down and has also a bigger size. It allows complex data types, so I mean you can save an as a JSON, as a column, and it understands it. Well, and as said, focus is minimal size and high writing efficiency here. And it also contains a schema. So where column name type null values are saved, and this is inside the so-called header of the file as a JSON. So you can see here on the top right, you see the header, and then you see the different data blocks where the data is divided in. Well, schema definition, of course, makes it self-describing, but also very efficient for the serialization to be performed here. Then we have schema evolution. So if you want to adjust the schema, add a new column, change the schema of the column, this is possible. And it's also a splittable format. So you saw the data blocks there, which makes it quite well splittable. It's very often used for streaming, for instance, for Apache Kafka, but unfortunately not always supported by some frameworks. So Spark is supporting it. That's a very important thing for now. So then let's jump up to our last format, PARQUET, which is also the newest format, developed by Cloudera and Twitter and launched 2013. And it also allows complex data types. So, and regarding complex data types, you could even save binary data like images, PDF files, etc. So, and here we don't have a strict row-wise or columnar format. So it's basically like a hybrid approach of columnar and row level. So we can have something called row groups, and underneath we have columns. You're gonna see it a little bit in the architecture. And focus is here really on efficient data queries. So rather the columnar focus using predicate pushdown. So predicate pushdown is something you might know from databases where queries are pushed down to the source. So for instance, if you want just to load one column, only this one column is then loaded into memory. And that's exactly what a columnar data format should do. It's by default highly compressible with Snappy, and the aim is not low size, but rather high speed in this case. And it has some very optimized columnar storage and efficient compression logic and encoding logic, which makes the writing but also quite fast and also saves like a significant amount of size. So it also saves the schema, but also saves other metadata in the so-called footer. So this is the reason why we had like the second job in Spark, and also makes, of course, the metadata, of course, a little bit bigger compared to AVRO. And well, due to this reason, it's also very self-describing and is also very efficient for serialization. It also contains schema evaluation, but I haven't seen it in practice to be used, to be honest, and it's also not as efficient and practical as with AVRO. And usually for updates, it requires a recreation of the PARQUET table. And what's also important is for a big data use case, it's splittable and suitable for parallel reads. So when we're looking into the architecture, and I also didn't understand this picture the first time very well, but basically we have the file divided into three groups. We have a header where we have some, well, basic numbers defined, but that's not very important. We have so-called row groups and a footer. So the row group is the row-wise separation of our data set, the logical division on a row level. And for PARQUET, it's defaulted to 128 megabytes. So that means the first chunk of rows up to 128 megabytes gonna be saved in row group 0. Then the next one, row group 1. And within the row group, we have then a columnar separation. And then additional, we have like more invisible unit of pages within each column where the encoding and compression magic is happening, which PARQUET is doing. So for instance, if you have a lot of repetitive values, what PARQUET is doing, it creates a dictionary for it. So it maps, for instance, the name in the table before we had to an integer. And then by that, if you have only 4 unique column values, for instance, you can save significant time. And compression time and size, of course. Well, it does some more advanced things also in the background to compress the data very well and encode them. And the important and most important thing for us for the performance later on is are the metadata contained in the so-called footer. So on every level of the file we have metadata saved. So on file level, for instance, number of rows, columns, and the schema. Then on row group level, also number of rows and the number of columns. And then on column level, we have also statistics saved. Min, max, null count, the distinct value counts, which is coming out of this dictionary I explained before for the encoding. And those can also be used for predicate pushdown. So for instance, we're going to see in the later session when we do, for instance, a count on a PARQUET table on the full data set, it's really fast. It doesn't even load the data because it just uses the metadata available in the footer. And that's really amazing. And it saves you a lot of performance time when doing big data analytics. So, and with that, let's come to a short summary. So we learned that CSV and JSON are both human readable, row-level formats which allow fast writes and are easy to open and process. And well, compression is possible, but it's not that fast and efficient due to the encoding and so on as in AVRO PARQUET, because it wasn't defaultly developed with having compression in place. And it also limits splittability with CSV and JSON. And CSV is further also easy corruptible. So I gave the example with the comma separation, then decimal numbers with commas, for instance. AVRO, on the other hand, is very efficient to save big amounts of data fast. And PARQUET is very efficient in loading data, including pushdown, where you avoid loading data which you actually don't need for your analytics. And it's also quite efficient at the same time for writing data. And then lastly, AVRO and PARQUET are not human readable. That's a small disadvantage, and they are also limited in the support, especially AVRO is not well supported everywhere. But for instance, for Apache Kafka, it's really well supported, and that's where it can also perform well with saving the big data amounts row by row or process them. And with that, thanks a lot for today's session. I hope you enjoyed it. If you liked it, comment below, like below, and of course, subscribe to my channel. So stay tuned for the next episode.